So, we are going to discuss that imaginary numbers, are they really imaginary and are they real numbers? So, what we are claiming here is that imaginary number or I, it is neither a number nor it is imaginary. So, let me explain how I can claim this. As we have already discussed in our previous lesson, if I have a point A here in the 2D axis where this is my real axis and this is my so-called imaginary axis, or rather let's say this is my x-axis, this is my y-axis. The length OA has two components. These components are derived by dropping perpendiculars on these two axes. From A, let us drop a perpendicular on the x-axis and mark it as OX, capital X. Let us drop a perpendicular on the y-axis and mark that point as Y, so OY. As we have already discussed, OA is square root of OX square plus OY square. Now this is from the standard Pythagoras formula. Because, just let me have a recap of that. These are 90-degree angles. Since OXAY is a rectangle, then AX and OY are of same length. From triangle OXA, OX square plus AX square will be equal to the square of the hypotenuse, that is OA. Hence OA is equal to square root of OX square plus AX square, and AX is same as OY. Hence we arrive at this. I'm not going to derive this here. If you need me to explain this, I can do that as a separate lesson, as a recap. So the way we write this is that OA is OX plus IOY. This is the real part, this is the imaginary part. Now, I is neither a number nor imaginary. Why I say that? I basically explains that there is a probability of a vector rotating in such a way that it leaves the x-axis and the tip of that vector can be anywhere on this 2D page. Now let's say I'll just redraw this in a slightly different manner. Let's say OY, let's say OA, pardon me, OA was initially aligned with the x-axis. A would have been a point here. Let's mark that as A prime. That was the initial position of the point A. I'm trying to create draw a circle, and this is like 1/4 of the perimeter of the circle. So if the point A prime undergoes a rotation of 90 degree and reaches here, and you mark that as A double prime, then practically OA prime, I'm just marking it with a shaded diagram, which kind of represents a tangible object, maybe a scale or a stick or something like that, a pencil or a pen. So that just underwent a rotation of 90 degrees. So OA prime and OA double prime, magnitude wise, they are exactly the same. Now, what is A prime or what is OA prime? OA prime is denoting a magnitude of OA prime units. This x-axis will have units. So let's say for a real number line, anything towards the positive side, the unit is +1. Anything towards the negative side, the unit is -1. That means if I move ahead 4 points here, each point is 1 unit away from the previous point. So if I move to this point, this is 4 units. Since the unit is of 1, so it is 4 into 1, that is 4. The length is 4. Let's explain it in a slightly different way. Let's say if the unit was kilometer here, then this point 4 would have denoted 4 kilometers. If it was meter, it would have denoted 4 meter. If it was second, it would have denoted 4 second. So it is 4 units or OA prime units. The way the unit is defined gives you the absolute understanding about what OA prime is. Now when A prime moved to A double prime, even though the length is still the same, this is still OA prime, OA double prime unit on this y-axis. Now this axis, this vertical axis, has its own unit. The unit is I. That means the actual value of OA double prime is basically OA double prime units. And just like the positive part of the real axis, units multiplied by the value. That is what gives you the absolute understanding about the magnitude of that quantity. So if the unit is I here, so OA double prime is actually I into OA double prime. So that means when you multiply something by I, it rotates by an angle of 90 degrees. If you further multiply by another one more I, if you multiply that with OA double prime, this will drop back here. Let's say new marker here. Let's say it is B prime. Then OB prime is definitely equal to OA double prime equals to OA prime in terms of the value. But this is on the negative side of the real axis. So the unit is -1. So OP prime basically minus of OA prime, negative OA prime. So what did you understand so far? What you understood is that I is not a number. I is a concept which just tells that this is a unit on the vertical axis. So yes, I is not a number. And it is definitely not imaginary. Even though we call it imaginary axis, it is not imaginary. The concept of rotation is very much real. Since we needed a way to represent rotation for the number system, we introduced the concept of I. I is neither a number because it's just a multiply factor to show that the quantity has rotated by 90 degrees, and it is not imaginary. It is tangible. It is really a tangible quantity, just that it is along the y-axis. Please do let me know if you need any more explanation on this, and we can go deeper into the concept. Thank you.